So we're here at the SID Display Week 2019, and hi, so who are you?
Hi, hello, I'm Filip Augstol. I am a product manager at the XTPL company. We specialize in printing solutions for the flat panel display industry. We can achieve ultra-precise feature sizes on the order of 1 to 8 microns.
And this is for what kind of market here with the Display Week? Is it for display industry?
Yes, indeed. So we offer solutions for the flat panel displays.
There, yeah. So, what are we looking at here in the video? What's happening?
The video is a presentation of our company. We have around 40 people back in Poland, and what we produce are the printing heads together with the inks. So we are able to provide a complete solution for the display manufacturer.
And what does it show here? It's very small, what you do?
So our core competency lies in the open defect repair. So for example, if we have a broken metallic line in the TFT backplane of a flat panel display, we can come in and print a detour that avoids the affected area. We can do it with an extreme precision of 5 microns.
So if there's a broken what?
There's a broken metallic line, so there's no electrical connection in the TFT backplane.
That means a defect?
Precisely.
So you fix the defects one by one?
Yes, we can do that.
So which kind of displays have defects?
Pretty much all of them, and it's a big issue for the manufacturers.
But
So,
don't they have ways to make them defect-free, right? They've been working on that for many years, but the newest displays have all kinds of new
precisely.
things.
So as you're pushing the envelope and you're trying to move into the next generation displays, it becomes more and more to keep the yield up, and that's exactly what we help with.
Can you show here a little bit? What is this equipment you have here?
So this is just a demonstration of our open defects. Here you can see a broken metallic structure with a real-life detour printed on.
This is real right here?
Yes, this is just here.
So this is what's there. What is this thing that you have under the microscope, or is it a microscope?
This is
that
an
your
example of
equipment.
This is an example of electrodes. These are simulated breaks in the TFT backplane panel.
Simulated breaks.
Precisely. So these are the simulated defects, and then you come in and print on the line that repairs that defect.
Is this other simulations here, or?
Yes, indeed. So these are just examples of the repaired defects. This is very important for the manufacturers because the materials that are used for the flat panel displays are extremely costly. So the cost of materials amounts for around 60 to 80% of the whole cost of the finalized display. Therefore, the manufacturers have big interest in increasing the yield.
60 to 70%.
Yeah.
Is a bad yield. Is all the
No, these are the
broken
costs of the
things.
materials that are involved in producing the display. Therefore, the rejection of the displays from the production line due to defects are extremely costly and undesirable.
And you go to 4 microns, or how small?
So we can go from 1 to 8 micron feature sizes.
And is that good for what? 4K displays or not?
This can be used for much higher resolution displays. So with 1 micron dot size, you can go up to 3,000 PPIs even, which opens up applications in VR, AR, and so forth.
So a 4K display for you is easy.
I wouldn't say it's easy,
Or an
however,
8K.
we can do it out of the box, yes.
And then all these AR, VR, tiny little high DPI displays is your potentially, you can
Precisely.
go in there. And
We are trying to open the markets in this area as well.
what is it showing here?
Here you can see a foil that has been bent with the conductive lines printed on it. And you can see under the microscope the conductive lines. So here you can see the parallel lines that are metallic and they are still conductive when the foil has been bent. This proves that our material has some stretchability as well.
So these lines are your material.
Yes.
So how you, what, this is very special for the market, what you do?
Yes, of course. Yes, we are reducing the feature sizes. You can see that the current inkjet standard is on the order of 50 microns, with the cutting-edge technologies being able to achieve 20 to 30 microns. Our technology is able to go an order of magnitude down with the ultra-precise deposition of material.
Order of magnitude down compared
Yes.
to anybody else?
Compared to any other inkjet printing on the market currently.
There it shows stuff that's going very fast.
Yes.
Is that related to what you do?
This is just an example of semiconductor industry that's very much related to the flat panel display industry.
Your background is in the semiconductor or the display?
I'm a
or-
material scientist, and it's a very natural step for me to get involved in the flat panel displays.
And where's your company based?
Our company is based in Poland. Our headquarters is there. However, we have offices in the Silicon Valley, in Sunnyvale, just around the corner from here.
So here, the SID Display Week is perfect for you to make connections
Indeed,
with
it is.
the whole industry.
It's proven to be very effective. Yeah.
And what do you show here? What is this talking about?
Here we have a number of quantum dots that have been deposited with our ultra-precise deposition methods. These are slightly bigger feature sizes, on the order of 5 to 6 microns. You can see here our precision in deposition, both in the amount of material deposited, as well as the density and spatial arrangement of the dots.
So, are you able to automate all this, or is manual?
Precisely. This
stuff?
is all an automatic process that it's able to run on the production line of the flat panel display manufacturers.
So you put the display in, it identifies the defects, and it fixes them,
Precisely.
and it just works.
So we work with the automated inspection equipment, which identifies the defects for us, gives us the coordinates of the defects, and then we come in with our printing head and repair it.
And you've tested this, a whole bunch of stuff.
So we are at the moment at the point of industrial implementations. All of this technology has been proven and tested in the lab at the industrial yields. However, now we are working with our partners to implement our first prototypes on the production lines in the FPD industry.
So what's the next for you? You say you are looking for partners to get into the big time, or what's it called?
Precisely.
To get into.
So we are looking for industrial partners that will help us to make the step into industrial implementations of the open defect repair. Looking forward, we are looking to provide complete solutions for additive manufacturing of the flat panel displays, including the position of organic materials for the OLED displays, as well as quantum dots and others.
Don't they usually in the industry like to see proven, what's called demos of it working? Or are you able to prove some demos, or what is the stage you at?
Of course they do like that, and we are working with our partners to provide the first prototypes that will give us this validity. However, the feature sizes that we can achieve and the competitiveness of our technology makes even the biggest players come over to us and try to find ways to work with us.
It's got to be really interesting this phase, right? To be discussing with giants and saying hey, and they're like, really, and then you say yes, of course, it works.
It's a steep learning curve, and we are learning as we go. However, we believe that we can deliver what we promise.